Your call, people. What questions do you have?
Maybe a little bit more kind of drive the demand, not like actually take the derivative, but like you send it up.
Okay, so a demand function is usually written price as a function of quantity. So let me just start with an overarching idea. When prices are high, do you expect to sell a lot of things or a few things? So I would expect that when I have a high price, I should have a low demand, a low number, and vice versa, right? If prices are pretty low, a lot of people will buy this thing. So I expect a graph that goes that way. High prices are correlated with low numbers of sales. Low prices are correlated with high numbers of sales. I need some information about quantity and sales somewhere in here. So if I'm selling when the price is, I don't know, 9, I'm selling 200 widgets. And when the price is 5, I'm selling 375 of them. I can create a straight line equation, right? All you have to do is draw the line between those 2 points. And that's a demand function.
And the context of 60 days then, is the second point kind of like indirectly?
Yes.
It's raised by the
I now have a new price and a new quantity, don't I? There are 2 things to remember. We are doing as simple a demand equation as possible. That's why it's a straight line. It is more realistic to use a more complicated demand equation. We'll save that for a modeling class where we talk about how to construct different kinds of models. A straight line is simple enough in this case. Secondly, I then use this demand to build other functions because I can then say, oh, the revenue I bring in is the selling price times the number sold. But number sold is exactly the same value as our quantity up here.
So would you need an entirely different equation because given cost of materials?
Because cost is completely independent of demand and of revenue, right? Cost is, again, simplest possible definition of cost, right? Cost per thing times number of things, same idea, right? Now, if I am being more general in a business context, Micro 101, cost per unit isn't the only cost I encounter as a business owner. Because I have equipment costs. I'm going to have to buy the machinery to put together my thingies, no matter if I make 1 of them or 1,000,000 of them. I've got to buy the building or rent it, right? I've got, in addition to this, I've got fixed costs. In this case, and 68. I don't think we're dealing with fixed costs at all. We're only dealing with the variable cost based on the units. We're not worried about the overhead. But yesterday, on my drive home, the news was talking to 3 different farm-related people about the challenge today before the Supreme Court on the Trump tariffs on international trades and international goods. And they were talking about, oh, well, all of these changes to the soybean production, and they were talking to farmers, and they were talking about the government shutdown and how farm aid isn't going out. They were questioning whether or not those people will make a profit this year or not. And this is exactly what they spoke about, word for word. Hey, I spent all this money to buy equipment, to buy seed. Oh, selling cost per unit, per acre. I had to buy this much seed. And now I can't save seed from last year because they keep changing stuff and it doesn't reseed. Farming is a whole other issue. But this is the simplest mathematical model. Better? More questions? Yes, ma'am. On which section? 4.9, 1 life, 46. 46. So would you rather do 45 or 47? Okay, 45, f double prime of x equals -2 plus 12x minus 12x squared. One of those was not a minus. Yes. F of 0 is 4, f prime of 0 is 12. Now, I'm particularly happy about this because I have one condition about f prime and one condition about f, which allows me to solve for the constants along the way. I want to go from f double prime to f prime. I take my antiderivative. What happens to my -2? It currently has no x's, right? That's x to the 0 power. I'm going to raise the power by 1, so it's going to get x to the first power. If I'm being pedantic, it's x to the 1 over 1, dividing by 1, big deal. Same thing with the x, I raise the power, divide by the new power. Same thing with the x squared. But wait, there's more. What else do I need? Plus c. I can simplify this a little if you want. I think it's advisable in this case. You could rearrange to put the cube first and put it in descending order of powers if you want. You could put the c at the front and write it in ascending order of powers. I don't care. But now, this is f prime of x. This is my general antiderivative. I have a condition about f prime in my list of initial conditions, so I can plug that in and solve for the c. F prime of 0 is 12. 12 equals -2 times 0 plus 6 times 0 squared minus 4 times 0 cubed plus c. Everything there except the c is multiplied by 0. It's gone. So c is 12. I'm sorry? Oh, yes, thank you. Good. No, but this side is equal to c. So c is equal to 12. Now write out the equation. for f prime with the number in place of the c. So let's recopy this thing, but put the value where it goes. You could leave the plus 12 on the right end. I decided to put it on the left end. Again, doesn't matter. What do I do now? But not until after I've gone up another derivative, right? This is f prime. We want f. To use that, I need f, not f prime. Take the antiderivative a second time. Same as before, raise every power by 1. Divide by the new power in each case. And at the very end, my infomercial voice comes back. But wait, there's more. Add your C. Now, there's absolutely no reason not to use a C again here, because I don't have any more C in this problem. I've already used it. I can use the same letter twice, provided I'm not using it twice at the same time. And now I can put in that 4. Again, I think it might be simpler, easier if I simplify all of these coefficients first. And if f of 0 is 4, that means 4 is equal to 12 times 0 minus 0 squared plus 2, 0. Plus, that's all 0, isn't it? Except for the c. And now I have f of x. The very last step is to write my equation for f of x. If you had left the plus 4 on the right, I'm not going to be upset. But I like having my powers in order, regardless of whether they go from small to large or large to small. That's just me being a pain in the ass. Better? Wonderful. Yes, ma'am. 14, like 4.9. 15 or 13? Yes. Yes, it would. I don't see one, and that's why I was going to the one that was a division and or just the fraction, the roots. But the idea is the same. Okay. So 15 says I am looking for the antiderivative of little f of t is 2t minus 4 plus 3 root t all over root t. Well, first of all, roots are powers. What powers? Okay. This root is in the bottom. If I take it out of the bottom, that power becomes. So I'm going to rewrite this. And then it becomes multiplication, doesn't it? But it becomes multiplication. So let's just distribute. When I multiply things with the same base, that's t to the first here. What do I do with the powers? So that 1 minus a half becomes 2t to the 1/2. And then here, and then here, and now it's just power rule. Now I know what to do with it. Add 1 to the power. 1/2 plus 1 is 3/2. Negative 1/2 plus 1 is positive 1/2. And the 3, which has none, gets 1. Let's see. Simplify the numbers. Fractions in the bottom come out and get flipped. Now, as far as I'm concerned, you can stop right there. The textbook will not like fractional powers. And so it will say in the textbook that I should rewrite this as a square root of t. Well, this is also a square root, but it's t cubed. So it's either the square root of t all cubed, or it's the square root of t cubed. Either way, I don't care whether you do that part or not. If you leave it just like this, I'm perfectly happy. I don't know how to undo the quotient rule. I think it's not worth wasting my time at the moment. So let's fix it so we don't have to. Better? Gracie. Yes.
You said is price equal to the function quantity. Does that mean like that doesn't mean demand equal price, right? So how would you like?
No, my demand equation is the relationship between the price and the quantity. So the equation is written this way rather than quantity as a function of price. Again, this is the economists decided that quantity would be the variable I'm thinking about as opposed to price being the variable I think about. So I need to write it as price is a function of quantity. Yes. So 45 or 15? This one. I got this, take its derivative, see if you get that back. The problem is what you're going to get back is going to look more like this, right? So you would have had to have done this algebra in the first place to know that it really matches. But yes, antiderivative and derivative are flip sides of the same coin, right? So if I did the antiderivative, I should be able to undo it and get back to where I started.
Any question on the exam that is explicitly just rolls through?
Explicitly just. This is my problem, is that I wrote the exam last week and I honestly don't remember. Explicitly Rolle's theorem. Nope, I have no idea. It's long gone. I flushed it out of my brain to write the stats exam and to write the DiffyQ exam, which are next week. So no, that's gone.
74.
Yes. If the two items pass one another, then there are two things that are going to be true. At some point in time, they'll be the same height, right? And before that time, one will be higher than the other, and after that time, it'll be reversed. So I need to know three things. I need to, do they have the same height at some point in time? And then, before that time, which one is higher? after that time which one is higher. Because maybe they caught up and then separated again.
So it wouldn't be sufficient to say that if this one was thrown first, but it landed last and they had.
Oh, no, if you can show that, then at some point, yes, absolutely. I tossed ball A first. I tossed ball B second, but ball B hit second, ball B hit the ground first, right? You know, ball B that I tossed second would have to hit the ground first for me to be absolutely sure it passed this one in the air.
Not even the same height though. Let's say maximum height.
Nothing about maximum height. They have to be the same height at some point. I need another object I can throw in the game. Ready? Did they pass each other? Yes. Were they the same height at some point? Yes. Were they the same maximum height? Not at all. That's fine. They just have to have the same height at some point in time. And since you have a height equation for the first ball from the example, and you've derived the height of the second ball in the homework problem, you can set them equal to each other and find out when they cross, if they cross.
Would you show that one was higher before than?
Back up the time, tell me the height of each ball, right?
Oh, so.
What you're really doing is making a sign chart of the difference in the height. Look before the time where they're the same height. Look after the time when they're the same height. If ball A is above ball B, then it's the same height. And then ball A is below ball B. Hasn't ball A crossed ball B? There you go. Or vice versa. I don't know which one's moving faster then.
That question showing, like if I were to set the height equal to each other and then solve for the time, that time would not be sufficient to show that they pass each other. I have to like plug that back in and find out heights first.
Well, if you plug that time in, you should get the same height, right? Then plug in a time just before that in each one, and then plug in a time just after that in each one to find the height. And you say, oh, I'm making numbers up. They are the same height at 100 feet at time 3. I know this is wrong numbers. At 2.9, ball A is at 105 feet, ball B is at 103. So ball A is higher. At time 3.1, ball B is at 97 feet, and ball A is at 95. So it must have passed it going by. It means to pass, right? Just knowing they were the same height at some point doesn't tell me I got in front. I might have pulled alongside and then faded back. It's a falling object, though. I don't expect its speed to change much. A bird came by and grabbed it out of the air. No.
I would never set them up with two reference that example.
You wouldn't. You'd have to be given information about both balls.
I guess just, how did you know to set up the lawsuit acceleration?
Oh, the only thing I know about a falling object is gravity.
You just have to know the line.
Or in this case, 32, because we're in feet. I have to know gravity. Although the bad joke about Newton is there is no gravity, the earth just sucks. Pull everything in. Which, by the way, was the original idea. Like attracts like. And thus objects that made of matter fall to the larger matter, connecting to the source, which is the earth.
So how many equations run the optimization and something like this? Are we going to have to just?
No. I'm expecting nothing more than you would have learned by 9th grade geometry, by earth sciences at best. Otherwise, I've got to give you stuff. Maybe this econ stuff that we've mentioned all throughout the semester, that sort of stuff. I've provided you with examples like that. I try not to make stuff you have never heard of before, which is why when that somebody came in with question 64 and said, "What is this Coulomb's law thing?" I went, "Oh, that's the wrong problem." So I'm not expecting you to have all these problem settings in your head. Basic geometric formulas, examples we've done a lot of or referenced repeatedly. Otherwise, no. More question. This is why I was happy they gave me the honeycomb equation and the problem about the dihedral angle of the honeycomb setup. Maybe I wouldn't have known that to save my ass. Ask me more stuff. Yes, ma'am.
The first one I did, that was great, so the equation here, that's my next.
Which section? Okay. For number 60, you said? 68. So this is our demand equation idea, right? Right. Well, yes, because that reversal means that I'm trying to look for the price that will give me the maximum, and that's harder to do. To do this all as function of price is much more difficult rather than do it as the number of necklaces, right? He's selling necklaces. Yes, she says she in the book. Otherwise I wouldn't be able to presume. Yeah, so I have to swap those two variables. I agree with you. I think it would make more sense. I have control over the price. I can choose the price. Shouldn't that be my dependent variable? The economist said no. Well, what I do with is I say, well, what am I looking for in the process here? Find the demand function, assuming it's linear. If the materials cost $6, what's selling price? Okay, I could try and do this in terms of price. I could, but it changes how I set up this equation. Because how do I figure out cost if everything depends on price, right? Somewhere in there, I need to figure out how to adjust costs. The only way I can do that is in terms of number of units. And that's why foundationally in economics, we think of objects as the variable that the market will select for. The unseen hand of the free market, to quote Milton Keynes. What's the definition of profit? No, I don't give a damn about technical definition. Profit. So it's how much I brought in minus how much I spent. Revenue minus costs. And don't we have a revenue and a cost equation? Therefore, you can make profit. Which was, again, a mention on the news last night, as the farmer in question said, yeah, well, the tariff, I have to eat some of it, but I have to pass some of it off, and that's affecting my profit bottom line. Yes, ma'am.
So in Berkeley 971,
Yes.
question 8, it says like find the derivative, antiderivative of a function, but the function is the derivative of products. How do I notate that I'm speaking the antiderivative?
Well, simply because it told us. We don't have a good symbol yet for take the antiderivative. I'll need one, but I don't have one at the moment. And that's why normally what we've been doing is just using the capital version of the letter to go from little f to big F. But I don't have a better symbol yet. That's okay. One of the interesting things that comes out of this idea, we'll see in next week, is that the antiderivatives play a major role in the other main problem that calculus was developed to solve. But that's tomorrow. More questions? Yes, ma'am.
You know,
Uh-huh. Okay.
so is that label picture wrong?
So I think if you've labeled your picture with, what I called L, you called W, that's fine. But it's going to change the way we set up the garden, isn't it? And your garden will go this way where mine went this way. And then the question is, do we still use the same amount of fence? And if the answer is yes, that's fine.
Because it's.
Yeah. So you minimize the amount of fencing. It was the same perimeter, so we used the same amount of fence. But instead of laying out wide against the house, you laid it out narrow against the house and deeper into the yard. Okay. I will say that the reason I pulled that particular problem is that it's one of the examples in the text where they draw a bunch of pictures. And if your version looks like this and my version looks like that, or vice versa, that's fine, as long as we use the same minimum amount of fence. More questions? Yes. If you are finding the general antiderivative, yes. If you are finding a specific antiderivative, like you were given the initial conditions, then you shouldn't end up with a C, you should end up with a number. And it is possible that the C is 0, in which case you can just leave it off. My high school calculus teacher, Maria Soto, University of Havana. I went to school in Miami. Maria Soto graduated the University of Havana. She was this tall and about this big around. This woman was a barrel, and I had her at 7:30 in the morning. I thought I was going to die. When we did antiderivatives, she said, as soon as you've done the antiderivative, I need to see that plus C. If you're doing algebra and then you put the plus C on the next line, you forgot it on the line above, that's a lost point. For every line it's not on where it's supposed to be, I lost a point. I got a homework back with a negative score. I will never forget this plus C again. And it is Maria Soto's fault. God bless that woman. More questions? I'm sorry? I cannot do a problem from the exam. From the review, yes, pick one. Tell me what you want me to do. Okay, read that problem off to me.
Five squared x minus 2 plus C.
Okay. Because this is the whole Megillah, I got to do all the stuff in section 5. So let's start at the very beginning. What does F tell me? Domain. Sine and cosine are defined everywhere. But sine and cosine are periodic. They repeat. What's the period of cosine? When does it repeat? Cosine of x. How long is one period? It is 2 pi. From 0 to 2 pi, we go up, down, back up. Same thing with sine, only we start in the middle, go up, then down, then up. So the period is 2 for both of these. That means the period of this whole thing is 2 pi. If I know what's going on between 0 and 2 pi, I know everything. So I'm going to make a note to that effect. Period of 2 pi. Look at 0 to 2 pi only, then everything repeats. So I really only care what's happening from 0 to 2 pi. And if I know what's going on in there, I can deal with everything else after that. Cosine and sine have no asymptotes, vertically or horizontally. If I plug in 0, f of 0 is sine squared of 0 minus 2 cosine 0. That's 0 squared minus 2 times 1. That's negative 2. So I know the y-intercept is negative 2. If I go to set up for the x-intercepts, I'm going to have to set this thing equal to 0, and that's disgusting. So to hell with that, we'll deal with that later. Not going to do that. All right. Intercepts, domain, asymptotes, period. I think that's all I got from F. Now I start to look at F prime to figure out intervals of increase, decrease, maxima, and minima. F prime of x. F prime of x, chain rule, sine squared. The derivative of sine squared is 2 sine x. Chain rule says, but wait, there's more. Minus the derivative of cosine. There's a negative there, so it becomes plus 2 sine x. Hey, I've got a 2 sine x in both of those pieces. If I factor that out, I'm left with cosine x plus 1. This is, again, defined everywhere. Sine is defined everywhere. Cosine is defined everywhere. I don't have to worry about where this is undefined. Critical numbers show up where this is equal to 0. 2 sine x equals 0 means sine x is 0. Where is sine 0? But wait, there's more. Sine is equal to 0 at 0, but it's also equal to 0. Think of the unit circle at pi. And then again at 2 pi, and 3 pi, and 4 pi. So every multiple of pi, but I only care about between 0 and 2 pi. Cosine x plus 1 equals 0 means cosine is negative 1. Again, I think of the unit circle in my head. Where is cosine equal to negative 1? Just at pi. So I only care about what's going on between 0 and 2 pi. So I'm not worried about to the left of 0. I'm not worried about to the right of 2 pi. I'm only looking in this section. Pick a value. Well, I'll make it easy and I'll split the difference. put pi over 2 in here. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. So this is 2 times 1 times 1. That's positive. We're going up. 3 pi over 2. Cosine is still 0, and sine is negative 1. 2 times minus 1 times 1 is negative. We're going down. Which means I have what kind of extreme going on here? A maximum at x equals pi. If I plug in pi to the original equation, you can tell me what the y value is. So I go back up here and I put in, I'm sorry, at pi. Sine of pi, we said was 0, minus 2 times cosine of pi, that's negative 2 times negative 1, that's positive 2. Now here's an interesting observation. This repeats itself, right? So what happens at 2 pi? We go going down, it's going back up. And at 0, because we'll take a copy of this and move it over to the left. So it'll be going down and going back up. So both 0 and 2 pi are minimums because we're going to repeat. But it repeats every 2 pi, which means I know the y value is also negative 2 there. Now, I only showed you one period, but literally I can make a copy of this here and a copy of this to the left, and I can keep going infinitely far to the left or right. Intervals of increase and decrease. I am increasing from 0 to pi. I am decreasing from pi to 2 pi. Plus 2 pi. Minus 2 pi. Plus 4 pi. Minus 6. Infinitely many intervals. Well, if I was sick enough to give you something like this, yes. So what would I say? I'd say I am increasing on 0 to pi, right? Notice I've left some space in here. I need to add multiples of 2 pi. You did this all throughout the trig class, people. When you added multiples of pi, you wrote plus 2k pi. And you're decreasing from pi to 2 pi. And I add the 2k pi to each one. So I figured out intervals of increase and decrease. I figured out maximums and minimums. That's all I get from f prime. Let's look at f double prime. You can use either version to do the second derivative. I'm going to use this one because that gives me a product rule. The derivative sign is derivative of the first, leave the second alone, plus leave the first alone, take the derivative of the second. The derivative of cosine is minus sine. So I get 2 cosine squared x plus 2 cosine x minus 2 sine squared x. Ew. Again, this is defined everywhere. I don't have a problem with that part. So I need to set it equal to 0. But I've got a mix of sines and cosines and I can't factor. Well, here's another thing I need to dig out of my memory banks. This would be a lot easier if it was only cosine. How can I change that? My favorite Greek geek, Pythagoras. Because sine squared plus cosine squared is equal to 1, I can replace the sine squared with a 1 minus cosine squared. Just move it to the other side. Hey, wait a second. 2 cosine squared minus 2 times minus cosine. That's another 2 cosine squared. 4 cosine squared x plus 2 cosine x minus 2. That is a quadratic equation. But it's a quadratic in cosine. Wait a minute. 4 ugly things squared plus 2 ugly thing minus 2 equals 0. It's a quadratic. Let's do it that way. I divide by 2. Helps if I divide everything by 2. And then I think I can factor this. So let's see. I want a 2u squared. I'm going to need a 2u and a u. I want a minus 1. I need a 1 and a 1, and one of those needs to be negative. One of those needs to be positive. I want a plus u. This minus this gives me the middle term. If you're looking at me like, how did you do that? Practice factoring trinomials, or what can I do instead? The quadratic formula. Because now I get u equals negative 1, or u equals 1/2, but u is cosine. Where's cosine equal to negative 1? Pi. Where's cosine equal to 1/2? Remember my unit circle? Say again. That's 45 degrees. That's root 2 over 2. Pi over 6, because when I'm doing cosine, start from here, 0, 1, 1 over 2. Okay, that's 60 degrees, pi over 3. But wait, there's more. There's another angle. Because not only is cosine positive in the first quadrant, it's also positive in the fourth quadrant. So the other angle I need is 5 pi over 3.
Did you go to doing this?
I just said it was quadratic. And I don't like factoring quadratics in weird variables, so I changed it to a u. Now I make a sign chart. And I do the same thing. And something amazing happens. Because when I do this sign chart, these are not all inflection points. We change from concave up to concave down at pi over 3. We change from concave down to concave up at 5 pi over 3. We do not change concavity at pi. So we only have 2 inflection points. Does that make sense? Wait a minute, wasn't pi where one of our maximum was? I can't change concavity there. I'd break my maximum idea. No, but that's the end of my intervals, aren't they? Now I can draw a picture. And if I draw the picture on my calculator between 0 and 2 pi, I can then copy it over to the left and the right, and I see my change in concavity, and I see my maximums and minimums. This is a long problem. For me to give you one of these on the exam is going to take what, half an hour? I better break this up into a bunch of different questions and bunch of different parts. So I don't think we'll get just one. Here, do everything. That would be bad. I will see you all tomorrow. Have a wonderful rest of your day.